Okay, so welcome to tutorial 6, I believe. So what we're going to do today is we're going to carry on looking at some advanced object orientation concepts. Now, the reason why this wasn't in the slides is because I didn't want to put it into your semester test, and I said that the semester test was from lectures 0 to 7. So some of the content we're going to discuss now is in the next lecture. And the next lecture, which we're going to have a look at, which I don't think I put on Eve yet, is looking at graphical user interfaces. So with graphical user interfaces, one of the things we're going to have a look at is a concept of inner classes. So there were questions in some of the previous lectures where we discussed, can we have a class inside of a class? And the answer is yes. You can have a class inside of a class. It's called an inner class. So we're going to have a look at that. We'll also have a look at something called anonymous inner classes, and we'll see what that is about as well. The reason why we need to know about these things is when we get to graphical user interfaces and we need to do things like the user clicking on buttons, the user clicking on menu items. We'll talk about what all those things are in the lecture tomorrow. But when the user does those things, we need to handle that in some way. And it has to be handled in a way that can be working on any operating system, because remember, we're working with Java. Java needs a way to handle that for any operating system. So it has an API in order to do that. It could be also ways to interact besides the graphical user interface. Other things you can interact with is a mouse and keyboard. So you need some way to interact using a mouse and keyboard. Now, when you write these different applications, depending on the application you're running, you need to have different things happen when you left click or right click or middle click or press certain key combinations. So all of that is done through things called inner classes and anonymous inner classes. So that's what I want to have a look at now. So this is still the same thing that we've been looking at for a while now, but I'm not really going to be working with those classes per se. So the education registration management system. But what I actually want to do is, suppose we can do it here. So let's take out that. We can take out. Okay, we'll keep these two. Actually, let's just keep everything there. We'll keep these methods around because we might want to do something interesting. So with this class is called revision. And if you look at this class, you can see that we have two static methods and we have a main method. So this is a class by itself. Now, some people are a little bit confused about a class that has a main method. You can still create an instance of this class. Remember, by default, the class has a no arguments constructor. I can still create an instance of that. But if you'll notice, we declared our methods as static, and that means that there's no instance methods here. Zoom in. There we go. So there's no instance methods here that correspond to the read and write. You'll see they're down here, but if I try and call them, then what I should get, just move this file handle up. What I should get here is by default, it's a warning. It's saying that a static method and the method name from the type and the class name should be accessed in a static way. I am accessing it through an instance. I shouldn't be accessing it through an instance. I should be accessing it through the name of the class itself. So that's how I should be calling this specific method. Now, if I have a method that is not static, When I have an instance, I can call that method no problem. If I don't have an instance and I try and call this, obviously that won't work because I don't have an instance to work with, and I can't call that method because I need an instance to work with an instance method. Okay, so that stuff you should already know. So let's look at something that is going to be new. If I want to create a class within a class, I can, and I can provide with visibility modifiers if need be. There can be situations where internal to the class, I want to have something that's only accessible through this class interface, API. I have to be careful with the word interface because API, the I in API stands for interface as well. There's Java interfaces. Interface is one of the design principles of object-oriented design. So there's a lot of different ways you can use the word interface. So the word which I wanted to use is a way to access information in this class, and we can provide something inside of this class. So you can have it as protected visibility, we can have it as private visibility. We can't have it as public visibility because if we declare this as public, okay, yeah, we can have it as public. If the outer class is public, we can have the inner class that's also public. And this class here can have its own things. So we can have data that we want to store here. And we can have access immutator methods. We can have a constructor. So all of these things can be inside of this class, and we can try and create an instance of this class. Now, you can't just access this instance directly. You can't just say writer, especially if you're not in the same class. I think here, if we try and create an instance of this, this one will work because we are in the same class. We can access things that are within the same class, but if we were in a different class, that might not be so simple. Let's just fix this. So yeah, after I fix that error, the error I was looking for popped up. So here it says there's no enclosing instance of type provision accessible, and it must qualify the allocation with an enclosing instance type, and it gives us some code that would be the correct way to do this. Now the syntax is going to look a bit weird, but what this basically is saying is that in order to create a writer instance, I need to have a revision instance. I can't create a writer instance unless I have a revision instance. So how would I create that? Okay, and oops, did I get the syntax wrong? I probably got the syntax wrong. Yeah. So that syntax looks a bit weird because now I have a dot operator with a new, and I'm calling a constructor of an inner class. Now what's happening here is with this set of inner classes, they are tightly coupled in the sense of this is a class and this is an instance class that's available publicly inside of it. So in order to create an instance of this class, I need to have instance to create it. You can do a version where we don't need an instance, and we can do that by making the inner class static. Then I don't need to have an instance because it's now static. So there are reasons for doing one or the other. One interesting thing about inner classes can access members of the outer class. So inner classes can access members of the outer class. What I mean by that, if you look at these, the patterns that we declared here, what we should be able to do is be able to access because they're static, it won't be accessible. We can access the instance methods instead. So we can access something like test. So this is another different syntax you'll see again. Because I'm accessing something from my outer class, I need a reference to my outer class. So I call the class name dot this. That class name dot this references the outer class. And then you can process and work with that way. Now, at this point in time, the examples I'm giving here, it doesn't make much sense. It doesn't seem like there's any reason to do this. When we get to graphical user interfaces, I can show you more detail why we need to do this. Yeah. Oh, okay. So yeah, this super keyword, that was the Mr. IDE said, I'll put this for you. But if I look at the constructor here, what is the superclass of writer? It always has one. Object. So if I look at the constructor here, it will take me to the constructor of object. So yeah, let's just tell Mr. IDE no thanks. We don't need that part. So here we have that class writer, and then obviously you can call the appropriate methods on that class and do whatever you need to do with that. So the only thing that we changed there was how do we access this class? It's part of another class. Now there are certain situations where we want to create an instance of a subclass once, and then we don't really need to do it again and again. Now, most of the time, if we need to create a class just to implement one method that might be in an interface or might be an abstract class, and we don't use it again, and we need to create another subclass that changes the way that implementation works, another subclass of that, it can be very tedious to write 10 or 15, 20 different subclasses. So there is a way we can get around working with creating many subclasses, and that is to use something called anonymous inner classes. So an anonymous inner class is an inner class that is anonymous. What does anonymous mean? It means it doesn't have a name. If I look at the inner class we created before, it was a class called writer. It was available in the revision class. It was an inner class of the revision class. I mentioned that we cannot create instances of an interface. We can't do that. It's not possible. So one of the interfaces we created was this test interface. If I go look at that, it just has this method called test. And let's say that we want to have two things that we want to do with the test method. One test method will print out to the output stream. One test method will print out to the error stream. That's the two examples. Now, if I want to do this properly, I have to create a class that implements the interface and have the test method print out whatever to the output stream, a standard output stream, and then have the other instance, other subclass, then prints out the error stream. For that use case, it doesn't seem like I don't want to write two classes. It takes too much time too much things to do, create a new class file, Java file, all of those things. So let's be lazy about it. So here, we're going to have a little bit of a different syntax. I said we can't create instances of an interface, but there I'm creating a new interface. Or am I? If you look at the syntax here, it's creating a new interface. So you can see that it's creating a new with the constructor. However, there's some extra things at the end here. And if I look at this, this is basically an inline class definition that implements that specific interface. How do I know that? Because if we look at what's inside of here, there is exactly one method. It's being overridden, and that is the method available in my interface. Okay, so that's the one class. And then I want to have another class. And again, I can have another implementation of this class that does something different. Then what I can do is I can put both of these into an array. And remember, the syntax here is the array initializer syntax, so I don't need to say how many elements there are. I'm specifying the actual elements in the array. And then maybe I want to have a loop that loops over those elements. And then if I run this, we should see is our two messages. So here I'm creating instances of an interface for one-off use. If I needed proper functionality and I needed more things, I needed instance members, I needed other methods to declare, because if you look at this implementation, there's no other things I can work with. So I can't access that information. Let's try and do something a little more interesting. Let's say that I have message declared here in this method. Now, instead of printing out their own things, I want to print out message. Even though it's an inner class, I can access things in the local scope. So I can access things in my inner class that's in the local scope, as well as things that are available in the class which I'm working with. So here, if you want to, you can have write, but then obviously we need a handle. So I need that line of code again. And then I can access that in a class like that. So With this, you can create as many anonymous inner classes. They don't have names. And once it's created, that reference that you have, that's the only instance that you'll have in memory. You can't create another one that's going to be the same. Because as soon as you create a new anonymous inner class, it's a new, different type of instance. So there won't be subclasses. They won't be seen as subclasses of each other. They won't be seen as a similar thing, but they both implement the same interface. So the instance of the interface will still work correctly. Then there's another syntax we can use, and this syntax is a bit more complicated, and it comes from a different type of programming called functional programming. Anyone heard of functional programming before? One person? So functional programming is programming where you work more with functions and everything is immutable. So let that thing sink in for a little bit. Everything you do, everything you work with is immutable. You can't have a variable because by definition, a variable can't change. It is variable. So you can't do things like loops because what happens with a loop? You have an iterator, you have an index, it needs to change. That doesn't work in functional languages. Now, I'm not going to go into too much detail about functional languages because that's an honors course, which I present as well. But what I can tell you is that because functional programming is so powerful, a lot of imperative programming languages and Java, C++, etc., that's known as the other type of programming called imperative programming, they've borrowed some concepts from them. So one of the things you can do inside of Java is work with a concept that's found in functional languages, and that is having functions as data types. Just like you have a variable that can store an integer, you can have a variable that stores a function. Sort of like function pointers in C, sort of like that. So you can have some interesting things that go there. And the name of those types of functions are called lambda functions. It comes from lambda calculus, and that's the thing that functional programming is built on. It's built on lambda calculus. It's built on math. So I'm not going to go into too much of the details of lambda calculus. Some of you might be doing lambda calculus in your second year maths. Anyone doing lambda calculus? Anyone? Maybe second semester? So yeah, that's interesting things. Anyone doing, what was the other one? I forgot now. Okay, when I remember, I'll ask again. Okay, so here, what we want to do is we want to create a lambda function, and because I forgot the syntax, I'm gonna have to go look here. Okay, so lambda doesn't really work. We can't create an instance like this here. It has to work a little bit different way. So what I'm going to do is just create another method here so we can test it. we have this method. Did I make it static? I don't think I did. Nope. Okay, so this over here, that is the lambda function, lambda method. And what it's basically doing is, in the context of working with this method, it's basically saying this lambda is something that will implement this interface. And if I look at this interface, we only have one method, which doesn't return anything, doesn't take anything as parameters. And that's what's happening here. I'm basically saying we have something that doesn't take any parameters, and it gives me back an implementation where we do something. So here is what's going to be inside the method body. It's the same thing as saying, so this is using the lambda. And if I wasn't using the lambda, so if I wasn't using the lambda, I could write out things like this. Now, this only works if there's only one method to implement. If there's more than one method to implement in your interface, then this doesn't work. The syntax will not work correctly. But if there's only one method, then you can work with that interface like that. If you need to pass in parameters, so here we need parameters, then here we also need to pass in parameters. So if I have to show that, I have to create another interface, and then we have to implement it that way. So where you'll be seeing this quite often is when we write buttons inside a graphical user interface, and the user has to click on it. When a user clicks on a button, depending on which button they click, we have to do something different. We won't do the same set of actions for a different button. If we're looking at other things inside of a graphical user interface, and I'm going to use the IDE as a thing that has a graphical user interface. Obviously, you can look at other programs like Word or Excel, Visual Studio, whatever. Every program has a graphical user interface that you work with. Inside of most programs, you'll have this thing at the top that's called your menu bar, and each of them have different menus. That's a list that comes down, and each of the menus have different menu items. And those are also similar to buttons. When you click on them, they do something. And we're going to write applications where we build something like this. We're going to have a file menu. We're going to have an open. Might not have so many things. If we can find reason to do all of those things, we can. But most of the time, we're just going to be working with a simple interface. But we're going to do certain things. So, for example, if we click open file and we have a method to open a file, then we can call that method, open the file, and display it in some way, usually in a graphical way. If we look at the IDE, for example, when you open up source code, what does it do? You have here a different type of thing, but if I double click on this, it loads that file, it reads that file, and displays the text. It does do some extra things. This text editor has syntax highlighting, so it highlights it. But if we're working with, for example, our education system, can we have a user interface where the user can select a degree file and click open and then display that information? Yes, we can. That's what we're going to eventually build up. So each of those different buttons need to operate differently when you click on them, and that's why we'll see that we're going to create basically multiple instances of anonymous classes because each of the button clicks needs to do something different. There is a different way of approaching button clicking. You can have one gigantic method that handles everything, but then you have one gigantic method that handles everything. That's the thing we try and avoid when we do proper coding. Because if there's a problem, you have to debug a giant method. Otherwise, you only have to debug small methods like the ones we worked with so far. Okay, so there's still 2 or 3 minutes, but I don't think I have anything new that I want to show you. So I will be putting up the JavaFX slides when I get back to the office now, and then we will continue marking your semester test that you wrote yesterday. So you can have a look through the GUI with graphical user interfaces. I'm probably not going to get through the whole lecture tomorrow. I'll probably go through part of it and then look at code for another part of it. And then when we get to the practical lecture, we'll look at how to do JavaFX properly, and we'll look at the batch file again. Because remember, we talked about the batch file needing to change when we work with graphical user interfaces. So that change will happen next week. If you have any questions, I'll be here in the front. Otherwise, I will see you all tomorrow. So what we're doing is inheritance, not inheritance. It's implementing an interface. It's realization. And second question: can you get the paper? You can get the question paper after the SSA has been written. So when you collect your answer script, you can get the question paper then. Okay, I'm going to end the session.